Welcome to clickmeproject.com. Our project title is Learning ELM-Tree from Big Data based on Uncertainty Reduction. The main contribution of our process is to the data mining is defined to obtain the information from the vast set of data. That is, a challenge in big data classification is the design of highly parallelized learning algorithms. In order to resolve the over-partitioning problem in the decision tree induction, ELMs are embedded as a leaf nodes when the gain ratio of all available splits are smaller than a given threshold. Then we apply parallel computational to the ELM tree, which effectively reduces the computational time for big data. Finally, the transformation of learning concepts is hard to realize due to the dynamic increase of data volume. To overcome these difficulties, the parallelization of sequential classification algorithm is widely adopted. Decision tree, which has the advantages of simple implementations and low computational load, and classification algorithms for parallelism. Finally, we knew hybrid learning algorithm proposed to deal with the over-partitioning problem in decision tree induction. It adopts the uncertainty reduction heuristics and embeds ELMs or as leaf nodes when the information gain ratios of all the cut points are smaller than a given uncertainty coefficient. In classification process, imbalance features classified in position of their classes, the efficiency of ensembles over a wide range of data, disseminations, and of class imbalance based on the removal of uncertainty reduction. Initially, imbalanced datasets are collected and the datasets are undergoes under pre-processing performance. Then the pre-processed data are stored into the database, so that database are classified instead on the phase based on the alpha diversification. The generalization capability is largely influenced by the scale of the tree. That probability attributes are calculated. Then the ensemble problems are calculated on the process of order file. The classifications are classified on the basis of attribute consideration, and the ensemble problems are nothing but the data distributions are performed in the basis of techniques for training single hidden layer feed for the neural networks. That classifications is developed for ELM-Tree for the big data classification. And the possible distribution types of non-specificity, where there is a need to specify one object from another object. Finally, the data are distributed as a ELM finalization. An analysis on the time complexity of ELM-Tree for a training dataset with n instances and n continuous attributes. The training complexities of ELM and the C4.5 decision tree are used respectively. It will cost a complexity of to partition the training dataset iteratively and also to train the determined ELM leaf nodes. The computation of information gain and the gain ratio of the different cut points are all independent, which could be finished in parallel for find out the alpha diversification, that is different partitions to a sample set by using a ELM and CART data set. We firstly validate the feasibility of sequential ELM trees for small data set and then demonstrate the effectiveness of parallel ELM trees for large data set. The main objective of testing the performance of sequential ELM trees on small data set is to check the impact of different learning parameters, and the missing values are replaced by the unsupervised filter replace missing values. The sequential algorithms are implemented using the parallel algorithms. The pair experiments are conducted to the number of operating systems, that is the testing time, training accuracy, and the testing accuracy on the scale of the tree are evaluated on the performance evaluation after the ensemble problem find outing the balanced data. Now the demo of the process. Right click on homepage.java and select run file. click on image, we can show the another frame, uncertainty reduction frame, that considering the data set, and select the browse button to select the data set. Select data set and click open, then click load data set to view the load data set, then click to arrow to move over the next frame. Click data set. This is the preprocessed data set, and that preprocessed data sets are loaded into the database, and items are loaded into the database successfully. Then view the database, whatever is stored in the database. Click divergence. In this, classifications are performed on the basis of the attribute consideration as we discussed before the process. Then click attributes. The corresponding attributes are displayed here. Then click divergence for another attribute. Classifications are similar attributes. Classifications performed on the similar attributes. Click negative. Negative means is the attribute, one type of attribute. The positive and negative are the one type of attributes which is preferred in the data set, whatever we initially stored in the data set. Click alpha trace, which find out the dissimilarity between the diversification of the overall data, that is alpha diversification. In alpha diversification, we can calculate the information entropy. That information entropy is nothing but a probability distribution and represents the impurity of classes in a node. It is a type of statistical uncertainty that arises from the random behavior of physical systems. Then click load to store the data loaded. Then click view button to show the stored loaded data in the database. Click negative. That similar process take place in the another class type, that is attribute consideration, which is preferred before the process. Then click load. The same procedure for loading the data set. Then click show. Click entropy. The entropy is nothing but the possibility distribution between the each of the attribute considerations, that is the positive and negative, and denotes a type of non-specificity when there is a need to specify one of the object from a group. Since probability distribution is a special case of possibility distribution, we can also calculate the probability distribution. It describes the uncertainty arises from the human reasoning and cognition. Both are entropy calculation between the data present in the database, which are evaluated or classified between the databases. In this, we can find out the balanced data. Click alpha is equal to n button. We can find out the values which is calculating the binary cases, that is specificity under the binary cases in which two types of uncertainty binary classifications are performed, that is the attribute consideration, which is used for loading the dataset into the database. The similar procedures are take place for the another attribute type. In this, balanced datasets are viewed. Click show data to view the balanced data, which are possible data, by removing the impurity classes between the data present in the data set initially we loaded. Click performance evaluation. In this, we can get the classification problem comparison between the data set and the attribute classifications. N number of data sets, we can calculate the x number of impurities, then remove it from the process. In this, we use the ELM from uncertainty reduction, means a large data reduces the uncertainty, that is the unrelated or impurity data which are present in the data set. They remove the data which is based on the DT, that, and also for ELM. ELM is mainly used for find out the uncertainty reduction for a large system data.
Thank you.